You are now tuned in to the NetworkBruh, the YouTube channel that takes complex networking topics and dumbs them down to a more simpler language, more simpler terms, everyday layman's terms. Today's topic is section 6.1b. We've already covered HTTP and Telnet and SSH. Today we're just going to cover SCP and HTTPS. This is a topic in the CCNP route exam. It'll be known as the CCNP Enterprise exam. Let's go ahead and take a look at the exam blueprint to see where we came from and where we're headed. Hashtag labeveryday. Go ahead and visit labeveryday.com as well. All right, this is the exam blueprint implementing CISCO IP routing. I hope y'all can't hear these lawns being mowed right now. The exam code is 300-101. The new one will be exam code 300-401. And again, that is CCNP Enterprise exam. We just wrapped up. Well, we're just basically chopping up this section right here, section 6.1b, because there's too many, I try not to go over my limit with these videos. I don't want y'all to sit here in front of these YouTube videos for too long. But anyways, we covered Telnet, we covered SSH, we did a little bit of HTTP. Today we're going to do SCP, and if we got time, I'll go ahead and do HTTPS, even though it's already similar to HTTP. It's just a more secured version. After that, we're going to move on to finally TFTP, and then we'll be wrapping up the infrastructure services. So let's start off with SCP. What's SCP? SCP stands for secure copy. It's a more like secure version of FTP and TFTP. Basically, it uses the same mechanisms as SSH. So even the configuration is just about the same. You just got like one or two more commands that you have to add. And it is a protocol, a networking protocol that we use to pretty much transfer files from one device to another or one location to another. It's just that it's more secure copy. It offers encryption for data in transit and also authenticity. Let's go ahead and head over to the slides for the official definition. SCP stands for secure copy. Well, it's really secure copy protocol. It's a network protocol based on the BSD RCP protocol, which supports file transfers between hosts on the network. That's simply put. I ain't got to worry, get into all the other stuff. It uses port number 22, just like SSH. It's secure, obviously, because it's called secure copy. It has authentication. It's encrypted. The configuration is just the same as SSH. It's just that we have to add this IP SCP server enable part. This one you're more familiar with because there's a username and password, just like SSH. If you forgot what the configuration for that is the configuration there at the bottom if you need a little refresher. So remember, we have to have a host name, we have to have a domain name, we added some credentials, we got to do crypto key to generate the RSA modulus. You go to the lines and do transport input SSH. So you do have to enable SSH for you to be able to use SCP. Here's an example of a download right here where I circled in red because it took me a minute to really figure out how to really download something. You just type in copy. Don't worry about the rest of the stuff. It's kind of like a wizard after you do this first line right here in the circle. So copy SCP. Here's the syntax here. It's from and to. So you're copying from SCP to your flash. And that's what we're doing here. That's why this is a download example. It's going to ask you what the address of the remote host is, or the name of the name of it. It's going to ask you for the username. It's going to ask you the name of the file. You got to put in the password, and then after that, you should see it's the file transfers over. And now here's an upload example. Remember, from and then to. So in this case, we're copying from our flash to another device's SCP, or to another device via SCP, right? And it's going to ask you the same. It's going to be another wizard, just like, kind of like extended ping. You know how you just do ping and press enter, and it asks you a set of questions, and then it executes the command, right? So remember, it depends on what you wanted to copy from or to first. And that's the order you put it in. So remember, download is from SCP to your flash, from your flash to SCP to the other device. Let's go ahead and launch up GNS3 and experiment with SCP, and it's going to be basically the same topology that we use in the SSH lab. All right, so here's the lab we're going to be working with today. Let's go ahead and power these bad boys on. We got router 1 on the left-hand side, router 2 on the right-hand side. They both sit in the 10.10.10.0 network. This is .1, this is .2, and it's simple as that. Let's go ahead and console into these bad boys, and what we're going to do is have router 1 on the left-hand side, SCP to router 2, get a file from it, and bring it back to router 1. We're going to make router 2 an SCP server, right? Remember, this is a secure copy, so it's kind of like FTP, but it's just more secure, and it's using the pretty much a configuration like SSH. So the first thing we want to do is let's enable SCP. This is simple as that. Configure terminal. We just do IP SCP, right? What's the context executive help say? We can just do server. Configure server-side functionality. So we're going to make him a server, right? And that's with the server keyword. What's next? It says enable. That's how we enable it, right? Simple enough. Now I can cut this video off right here and tell y'all that's how we enable SCP. But what we really want to do is actually use it. We've enabled it, but we want to use it. So we're going to have, again, router 1, SCP to router 2, copy a file, and bring it right back. So now that we've enabled it, we need to also enable SSH, right? Because, like we said, we have to configure authentication just like SSH, and it uses the same mechanisms for authentication, therefore ensuring authenticity, confidentiality of the data in transit. So let's go ahead and enable SSH. Let's first of all, let's do a domain name, right? Let me fix this for you. We're going to say IP domain -name. And let's do NetworkBruh.com. Maybe one day in the future, I'll open up the website and do that. And when you get to the website, that's all you're going to hear. Let's go ahead and create the username. Username is going to be NB for NetworkBruh. We need to also escalate his privileges to privilege level 15, so that way he can have full access to this. The password is going to be, we can do also a secret as well. Password is going to be NB as well. So password and username is NB. How secure is that, right? But it doesn't matter because this is encrypted, right? We've done that. Let's go ahead and generate the crypto keys. So crypto key generate RSA. Remember that from the SSH video, right? We're going to do 2048. And remember, the higher the modulus, the key modulus, the stronger the encryption. Right now we've enabled SSH 1.99. The range is 360 to 2048 as far as the size of the key. Let's go ahead and go to the VTY lines and enable it along with the username and password. So my bad, line VTY 0 through 4. We're going to say transport input SSH. So now we're allowing SSH. Let's go ahead and do a login to check for the passwords. Login local. And I think we've done everything. We've enabled SSH. We've enabled SCP. Let's also check the directory here. That's something else I've been having to forget to do. There's no file in a directory. So there's nothing for router 2 to take from router 1 to take from router 2. So let's go ahead and copy the startup config to flash. And that's going to be the name of the file, router 2 config, router 2 -conf-g. Do you want to erase the flash before copying? No, we're not going to do that. So now we've done that. We saved the configuration for router 2 on the flash. So now there's something in the flash, right? It should be, do a dir, and there's a file. So now we're going to have router 1 SSH to router 2 and get that file. Well, we're not even going to SSH to it. We're just going to copy the file. And remember, it's from 2. So in this case, we're going to say copy. We're going to copy from SCP, the SCP server. We're going to copy from the SCP server to what? We're going to copy it to our flash. So copy from 2. Remember that syntax when you're doing this, right? Because if we're doing it the other way around, it'd be copy flash SCP, right? So we're going to be copying a file on here and sending it over. That'd be like an upload, right? Just like the example I showed you in the slides. We've done that. You just press enter. It's going to give you a wizard, pretty much, and ask you what everything is. What's the address of the remote host? Well, the address of the remote host we're getting file from is 10.10.10.2, right? So 10.10.10.2. We could also put the host name. The source username, what was the username? It was the network. So NB, right? What is the source file name? Well, we said it was, didn't remember it, so we're going to copy that guy. I think we already did, but we'll do it just in case. Again, R2 conf-g. That's the file name. When you bring it back to the destination, what do you want to name the file as? R2 conf-g? Do you want to do that? Yes. We'll go ahead and just press enter here. Do you want to erase the flash on your router 1 before you copy it? Now, I don't want to do that just in case I have some other stuff on there, which I doubt there's anything on here. We're going to say no. It's waiting. Now it's prompting us for the password. Remember that was NB, right? We press enter, and there we go. We've copied the file onto router 1. I should have checked the directory just to prove that. Let's check it anyway. And there's the file. We've copied it to router 2. So let's go ahead and finally move on to HTTPS. Okay, so moving right along. We have HTTPS. The HTTPS, which the S stands for secure, is basically the more secure version of HTTP. You know how you go on a website, right? You got to type in HTTP whatever, right? www. whatever, right? If it doesn't have the S on it, that means it's not secure. So that's why banks and stuff that that needs to be PCI compliant or has credit card information and stuff like that have to have a HTTPS on their website. You need to look for that. That's how you know it's a secure website and none of your information will just be out there. So it's similar to HTTP. It uses port 443 as opposed to HTTP uses what? That's right, port 80. It offers authentication of the website and also associated web server. It also offers bidirectional encryption of communication between the server and client. So basically, you get on the site, it offers encryption. That's how come our websites and stuff like that can stay safe when they have HTTPS. Right here is a sample configuration of HTTP, but it's using crypto CAs, which is certificate authorities. If you're not sure what those are, I'll leave a link in the description below. I don't want to get too much into that. I don't want to get too involved. We're just going to do a simple configuration of HTTPS using hardware. So we're going to mix it up on this one, right? First thing we're going to do is establish SSH on the desired device. So in other words, we have my hardware, which is going to be a CISCO 1941 router. We're going to establish an SSH connection to that. We're going to create an ACL that's going to allow my laptop into that, so that way I can access that router. And then we need to enable HTTPS with these two commands right here. So it's similar to what we did in the last video for just HTTP. Remember, it was IP, HTTP, and then server enable for HTTP. For HTTPS, it's IP, HTTP, secure server. That's the difference. So HTTP is IP, HTTP, server enable. HTTPS is IP, HTTP, secure server. And then we're going to create a username and password. And in order for us to use it, we need to put this command, IP HTTP authentication local. And let's not forget, I had to put this note for myself. When I was doing this, experimenting before recording, I forgot to log in local again. So I put this note here to not forget that. So let's go ahead and fire up the CISCO 1941 router and experiment with HTTPS. Okay, so right now I have the laptop that I'm using to record here. And I am consoled into my CISCO 1941 router. I want to show y'all again, but y'all know, y'all seen this router before. The first thing we said we wanted to do was establish an SSH connection. Before we even do that, I also have my this laptop plugged in from the Ethernet port, right? And then I have the cable going into router 1, which is just this one router. It's a simple topology. Right, so I'm taking this Ethernet cable. One end is on the back of this laptop, and as y'all can see, it should unplug here. I guess it's not going to do that. And I'm going to plug into GI00. So I'll plug into GI00. Right now, we already have a host name. Did we give it an IP address? That's the question. Let's show IP interface brief. See what we got so far. Okay, so let's go ahead and change the IP address. So configure terminal IP address. We're starting from the beginning here, right? Our interface GI00/0. We're going to give it the IP address of 172.16.1.1, 255.255.255.0. We're going to no shut. So we're 1.1, no shut. Change state to down. Let's make sure on my laptop that we have a correct IP address. So we're going to go to the command prompt. I haven't done this in a minute, right? And port number 3, right? So we're in GI0. Let me make sure we're in the correct one. We're in 01 right now. That's the problem. This is why I like hardware. So let's go to GI00. And now Do we have an IP address for that guy yet? We're disconnected right now. It says media disconnected. Let's take a look at our Ethernet ports here. So I have it set to 1.10, this guy, right? Let's change his default gateway. That's what we probably need to do here. Properties, I had experimented with this before. We're going to change this to 1.1. Okay, close. Let's see if we can ping the gateway now. Ping 172.16.1.1. And we got a reply. So now my laptop has connectivity with that, right? Okay, so now we're changed to up right here. And now let's go ahead and configure SSH. Y'all can skip this part if you want to, but we've done that already, right? So let's IP domain name. If you don't remember how to do that, go back to, I believe, the last video, right? We're going to say NetworkBruh, BRUH.com. That's going to be our domain name. Let's give ourselves a username as well, NB. Password, well, actually, let's do a privilege. Let's give ourselves full privilege. Password is going to be NB as well. Let's also generate the crypto key. Crypto key RSA, no, generate RSA. We're going to say 1024, so that's halfway, right? On this route, it looks like it's 360 to 496, so we can create better keys on this one, right? So we've enabled SSH. Let's also establish SSH connection and then create an ACL. Let's make sure we've completely done SSH. Let's allow a SSH. So we're going to go to the lines VTY 0 through 4, transport, input, SSH. So now we're allowing SSH. Let's go ahead and do these commands right here, right? We said we needed to secure server. Actually, let's create the ACL. Access list. We'll say 10. We're going to allow, so permit host number 172.16.1. We'll do the whole network. 000.255. We're going to log some messages here. What else do we need to do? And we're going to deny everybody else, right? So access list 10, deny any log. So we're denying everybody else. So let's apply that to the list, the access list. We're going to go to the lines, line VTY 0 through 4. We're going to say access class 10. Oh, my bad. Access class. What else do we need to do? Inbound. So now we've applied the access list to the VTY line 0 through 4. What else do we need to do? Okay, I think we've done with the ACL. Let's go ahead and do the HTTPS, what we came to do, right? So we get out of this IP, HTTP, and I'm going to show you what else we got here, right? We got access class. We can do, yeah, we'll restrict server access by access class. Secure server, right? Enable HTTP secure server. That's what we said, right? So secure server and carriers return. Now it's going to generate some keys. No autosave configuration was. You could issue a write memory to save the certificate. I'm not going to do that because I like to wipe this computer or wipe my router and start over from scratch when I practice. That's a good way to practice. You lab every day, right? Wipe your things clean and start from scratch. It's always best to have your topology set up if you have hardware. That way you could just get up and running. But me, I like to build stuff from scratch. That's how you remember some of the stuff that, you know, the fundamentals and stuff. Don't forget login local nor this authentication local. So let's go ahead and do the IP HTTP, right? We said authentication right here. So that's going to set the HTTP server authentication method. So IP HTTP authentication, right? We're going to do local, because we have a local username and password, which was NBNB, right? And I think that's all we really need to do so far. That's all we really need to do. We're allowing HTTP. We're allowing SSH. We've created the ACL. I believe we got to restrict HTTP server access. That's probably what we needed to do too. IP access class, or IP HTTP access class. The access list number was 10, right? We'll do that. And let's go ahead and see if we can, we're console into it right now, right? This is our console connection. Let's go ahead and create an SSH session. So now we're going to SSH to this router, right? We're going to create a new session here. We're going to create a new session here, an SSH session. Next, what was the host name of the router we're trying to get into? It's the default gateway, 172.26.1.2. We're using port 22, right? Because we're SSHing into it. What was the username? It was NB, right? NB. We'll click next. You could also do this with PuTTY. PuTTY is free. I just so happen to have secure CRT, right? Log into that. The session name is 1.2. We'll just leave that as is. All right. You know what I think we forgot? I think we forgot the login local. We did authentication local. I forgot the login local. See there? So let's go to the lines, line VTY 0 through 4, login local. You would think that this would have taken care of it, authentication local, right? Now, let's see if we can reconnect. We're denying everybody else. We're permitting 1.0 network, 16.1.0, right? That was the host name for this laptop. That's the problem. I know what it is. It's 1.1 is what we need to SSH into. That's what we need to do. We're going to create a new section. We do new session, right? And then next, and we're going to paste, the host name was 1.2, port 22, right? Username was NB. We're going to log on. Next, we're going to connect. And now we're getting the host key here. Notice we're getting a deny there, or permitted here. We're going to accept once. What was the password? It was NB. Click OK. And now we're SSH'd into the router, right? So we're SSH into the router. That's perfect. Fine and dandy. Let's see if we can HTTP to the router. Now we're going to try to HTTP into the router. We're going to HTTP ://172.16.1.1, right? We're trying to HTTP into the router. Site can't be reached. Why is that? Because this is not HTTP, right? So let's try to HTTPS into the router. HTTPS://172.16.1.2. Looks like it's loading up. Bruh. I ain't got my sound effects today. Left it upstairs. We're trying. My bad. It's not 1.2. It's 1.1. HTTPS://172.16.1.1. Keep forgetting that. Now we're getting your connection is not private. Just hit advanced. Proceed anyway. Unsafe. Now we're getting prompted for username, password, NB. Sign in. It's looking good now. And now we're getting a message that's giving this pretty much a EULA agreement. We're going to click yes. And now we have GUI access to our router. So basically a graphical user interface. So we could do the same thing we were doing with CLI right here. Now we can do it on the web. So we can access our router via HTTPS and do what we need to do. Also, when you're logged in, you could, basically manage the device from here. So let's say, for example, we go to DNS hostname. There's NetworkBruh right there. There's the host name. We can change it here. So basically, everything we were doing in the CLI, we could do it through the graphical user interface. So basically, we can shut down our ports. We can change the IP addressing. We can edit the host. We can edit the name, put a description and all that. We can delete ports. It's add a VLAN. It's pretty much everything we do in the CLI, but we're doing it through the graphical user interface. So that is my YouTube page. That is my Twitter handle. Go ahead and please subscribe to this channel. Share these videos on Facebook. Share these videos on Twitter. Share these videos on Instagram. Just share these videos. Let these people know, I'm trying to get certified and this is the way I'm doing it. Go ahead and hit that like button. Go ahead and click the subscribe button once again. Leave a comment below on what I could do to suggest or to make any suggestions on what I could do to improve my channel. And if I made any mistakes, for now, please go ahead and comment, like, subscribe to the NetworkBruh.